Hello, mathletes. This is the Math Guy, and I have created this channel to help those like me that struggle to grasp math and its concepts. If you find my examples and videos helpful, please support my channel by clicking the subscribe button below and the bell icon to receive more notifications and tips when I upload more content. Well, hello again, and welcome. This is now the third installment of graphs. And now we're going to go and look at some questions or problems where you don't have an initial equation. You have to derive the equation based on some of the information that the problem provides you, whether it be points or other forms of information that you may have to plot. So let's go ahead and take a look at some equations and some formulas that we need to, understand before we start, and then we'll get right to it. Okay, so let's take a look at some examples of where they give you information and you have to derive the equation to those lines, provided the information you're given. And in this example, we have 2 points. If you remember, your slope formula is y equals mx plus b. Okay, we need to find the slope, which is denoted by m. Okay, we need slope. And once we have the slope, we can use our point slope formula, which is y minus y1 is equal to mx minus x1. Once we use that, we can formally complete an equation for this line. Now, though the slope isn't directly given to you, you can derive it based on the information that you have. And this is one of the ways that tests usually find out if you actually know the concept and can use a lot of the formulas and ideas that they have shown you in their chapter. So you got to go ahead and use that formula. Let's write that formula again real quick so we can remember what it looks like. So your m is going to look like y1 over x1, y2 over x2, and they're both minuses. Okay, and I'll show you what I mean. What I mean by making sure that your points are correctly placed into the equation. Sometimes people don't put them in correctly. So let's go ahead and plug them in and see what we get for a slope. So my m is going to be equal to my first point is going to be, let's say, 11 over 8, and then 1 over 4. I usually like to do it that way just to keep me honest and making sure that I am putting my y's and x's in the right place, because if you don't do that, then you are doomed to fail with your slope. If your slope is wrong, everything else will just follow. So let's do it. Let's figure this out. So 11 minus 1, we got 10. And then 8 minus 4, we get 4. And we can reduce that. We can split that in half and say, well, this is nothing more than 5 over 2. So that's my slope. There we have it. We have a slope now, 5 over 2. Now we can go and say, okay, well, let's use the point slope formula to figure out what the equation of the line is. Okay, now we're halfway done because we can now use the second equation where y minus y1 is equal to mx minus x1. At first we didn't have m, but now we do. So let's plug in m and some points. So we can do y minus, and this is where you kind of have to be a little picky about what you want to use as a point. I'd always use the points that are small and easy. So, I mean, I can use 8 and 11. But I think working with small numbers here will help us in going through this problem a little faster. So instead of choosing 8 and 11, which you can, I'm going to choose 4 and 1 just because it's smaller numbers and it's easier to manage and easier to go through. So y minus 1 is equal to 5 over 2 times x minus my x value 4. Okay, so let's go ahead and kind of put some of these terms together. we're going to get y minus 1 is equal to, well, 5 over 2 x, and this is going to be, what, 5 times 4 is 20 over 2. Okay, so there we have it. Now we can still obviously, simplify this a little bit. For example, the 20 over 2, and I did that purposely just so I didn't just put an integer there and confuse anyone. So we'll say y1 is equal to 5 over 2 x, and then this is just going to be sorry, this is also a minus here, minus 10. Okay, all right, so now we got to just solve for y, and at this point it's easy. We have, we're gonna need, there's a minus 1 here, we're gonna add 1 here, we're gonna add 1 here, and then now this will go away, so we'll have y is equal to 5 over 2 x minus 9, and then just do the rise over run. So we know this line is increasing because the slope is not negative. So let's go ahead and I guess plot the y-intercept. If we do that, we set x to 0, and this will go away, and then you're just left with minus 9. So at x0, you're at minus 9. That's the easiest point. I don't even know if I have enough room. So minus 9, we're going to go from here with 1, 2, 3, 4, 5, 6, 7, 8, and 9. So we're like way down here actually for this graph. That's the point where it touches the y-axis. So we're gonna now just implement the rise over run, and we know that we read from left to right. So we're gonna go this way, and it has to be positive. So let's go up 5 from according to our slope. Our slope says we're 5 and then 2. Rise and then run. So we're going to go from here, we're going to go up 5. It's going to be 1, 2, 3, 4, 5. 1, 2. So your second point is right there. Okay, if you want, I guess, a third point, we can do a third point. Just make sure this line looks straight. So we can go again 1, 2, 3, 4, 5. 1, 2. So right here. So these are the points that you're going to need to plot your line. So there's your line there, and it's increasing as you read from left to right. And that's how you do one of these problems. You have to basically just find the slope if it's not already given to you, and then use your point slope formula to derive your slope. And then once you have your y-intercept, I mean, it's just using your rise over run. You've pretty much done your line. All right, let's try another example. All right, so in this example, we have the same thing. Let's figure out what my m is. So your m is your slope, and your slope is y1 over x1 minus your y2 over x2. Now another question that sometimes I also get, well, how do you know which one's y1 and which one's y2? It doesn't matter. It doesn't. You can do them either way. You can pick 1 point for your y1s and your other point for your y2s, and you can do them the other way, and you should get the same thing. Maybe why don't we go ahead and, I guess, do that as an example. We'll run through the second one quickly. So we have m is equal to 1 over minus 3, and then we have minus 2 over minus 2. Okay, I don't believe in negatives, so one of the things that I do is, if I have two negatives together, plus, 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 and plus. Okay, so this becomes nothing more than 1 plus 2 is 3, and minus 3 plus 2 is negative 1. So this is actually negative 3 as my slope. Okay, so if we did this the other way, for the sake of this example, minus 2 over then 1 minus 3 minus minus. Okay, I don't believe in minuses, so once I have minus 2 minus a minus 1. Usually I like to turn it to addition, so plus a negative. Two negatives together become a plus. So this becomes negative 3, and then this becomes minus 2 plus a 3, positive 1. Okay, so as you can see, this is also negative 3. It doesn't matter which point you use. Okay, so now that we have our slope, let's go and do our y-intercept formula. So we have y minus y1 is equal to mx minus x1. Okay, so we know our m now. We figured that out. So we're going to say y minus, and then the easiest point here, I think it's the one with the 1. I think that's the easiest. I think that's always the easiest. So we're going to go with the 1, and that's equal to 3 net minus 3, by the way. X minus, in this case it's a minus 3, so I'm going to write it down anyway. So be careful with your negative signs. Negative signs are usually, once you kind of mastered a lot of this stuff, usually people just, they get tripped up with the negative signs. It's even happened to me during one of these lectures. I had to go back and show you my mistake. So negative and negative, you can multiply those together. Negative and negative make positive. So that's a positive 3. Okay, so now let's go ahead and distribute that negative 3. Y minus 1 is equal to minus 3 times x gives you a minus 3x. Okay, now a minus 3 times a positive 3, this becomes minus again, so it becomes minus 9. Okay, so there you have it. You have now almost your equation, put together. So let's work this out. So we're going to add 1 here. We're going to add 1 here. And then your y is going to be y equal to minus 3x minus 8. It's basically another slope form equation. So let's eliminate this by saying x is equal to 0. So if that's true, then your y is just minus 8. So it's almost like the last one. Instead of minus 9, it's minus 8. So we're going to say 1, 2, 3, 4, 5, 6, 7, 8. So we're down here, okay? And our rise over run is basically minus 3 over 1. Always remember, if you don't have a fraction for your slope, if it's just a number, like in this case, you have to understand that a negative 3 is the same as just negative 3 over 1. I mean, it's just the way you write it. Let's go ahead and do this rise and run. My rise is 3 and my run is 1. Now remember, this slope is negative, so your line should be going this way, okay? Because we read from left to right. So you want to make sure that your line is going down. And that's important because that's going to determine how you're going to run. If you're going to run towards the left or you're going to run towards the right. So in this case, we're going to go up 3. 1, 2, 3. And now we're not going to go to the right. We're going to go to the left because this line has to come down. 1, 2, 3, and then over 1. So that's what my line should look like. Plot these points as best as we can. Your line is looking somewhat like that. Okay, remember, your slope here is negative. So since the slope is negative, we need to be decreasing. Had I decided to, go to the right, 1, 2, 3, and then come this way, my line would be increasing, and that's not the case because this slope is negative. So it's something we have to be careful for. Okay, let's go through one more example. All right, so here we have a case where your y's are the same. Let's see what happens when we have their y's the same. So let's go back to black. We have m is equal to y1 over x1 minus y2 over x2. So let's plug in the points. So we have m is equal to minus 8 over 4. And then here we have minus 8 over 2. Okay, minus, minus, plus, plus, negative and negative make positive. Okay, so 4 minus 2. So this becomes basically 0 over minus 2. Not like it matters. Okay, because anything over 0 just means 0. So if you notice, this line is going to be on the same y. We plot, let's go ahead and plot these points. We're going to say, well, 4, we got 1, 2, 3, and 4, minus 8, 1, 2, 3, 4, 5, 6, 7, 8. It's way down here. Okay, and then negative 2 here. If you notice, this line is just going to be this flat line. Okay, so let's discuss this for a second. You know, the equation to this line is just going to be y is equal to minus 8. That's it. There is no slope. The slope does not exist. Okay, what does that mean? That means that this line will never rise. It's just flat. Okay, and that's important. This line has no slope, which is quite different from the next line that we're going to do, because we're going to do another line to show the complete opposite of this case. Okay, so let's take a look at the next line. Okay, so this one says we have 6 and 1 and 6 and negative 8. Again, let's use our formula. y1 over x1 minus y2 over x2. So let's plug these in. If we plug these in, you're going to notice something peculiar about this setup. So we have 1 over 6, and then we have negative 8 over 6. Okay, we have minus, minus, minus times minus become plus. So this becomes 9, and this becomes 0. Now that's a problem. Anytime you divide by 0, you have a problem, because it means infinite. Sometimes they have it in the book as undefined, but that's what that means. It's undefined or infinite. I like to use infinite because I like to use the example of, let's say you have kids and it's candy, and you have 2 kids and you have 5 pieces of candy that you're going to give the kids. Well, if you never actually give them those 5 pieces of candy, when will you run out of candy? Well, the answer is never, because you never give it to them. That's what that means. When you divide by 0, you'll never run out, or the answer is infinite infinity. So let's go ahead and plot this and see what this looks like, because this basically looks like this. So we have a point at 6 and 1. So we're going to go 1, 2, 3, 4, 5, and then this is 6, and then up 1 is right here. And then we have 6 and negative 8. So we're going to go, basically, this line's a little off. So we'll go 1, 2, 3, 4, 5, 6, 7, 8. So we'll say right about here. So this line's going to look something like this. It's basically a vertical line. So a vertical line basically has an infinite rise, because you're always rising. You're not going to the side. You're always going up. So your rise is basically infinite. So that's the difference between those two types of lines. You have a horizontal line, or a flat line, that has 0 slope, and then you have a vertical line where the slope is infinite. Those are the differences between those lines, and sometimes they will come up, in questions and in tests, just to see if you understand those concepts. Be wary and be careful with those. All right, we'll wrap this up here. We're gonna do some more examples now on the last graphing concept, where we're basically gonna put all these concepts together. Hope to see you on the other side of that. Okay, thank you and bye for now. Okay, that'll do it for now. If you found this video helpful, please click the like button, as it will help me for future videos. If you have any questions or ideas for a video, please leave them in the comments below. Thank you. Until next time.